Hi, good evening, guys. Today we are from Group 5. We would like to present on overall equipment effectiveness. My group is consists of me, Daniel, and my friend Alf, and my friend Pang Tak Seng. Okay, what is overall equipment effectiveness? In short, is OEE. OEE is a hierarchy of metrics to evaluate how effective a manufacturing or production plant operation can be utilized. It is a simple and straightforward calculation, and it's a method to classify all the production losses. Basically, it's to identify the percentage of manufacturing time that is truly productive. What are the elements of OEE? So, OEE consists of three things, which is the availability, the performance, and quality. We will go through availability and performance and quality all the time inside OEE. So what are the one of the example of of availability is the setting up. Basically, setting up is we can see that the timings and the planning of the production plan or the manufacturing plan itself, and we have the breakdown or downtime. Basically, there's when we have lunch or we have maintenance or we have training. And the second factor is the performance. So performance of the manufacturing plant, basically sometimes we have a minor stoppage when we have a short of material, and then we have a change of shift. Sometimes we have the conveyor is stuck or jam, and then we have also running speed. Sometimes the running speed is not optimized, therefore the system design itself is not running as the best performance that it can. The third factor is the quality. We have this basically the startup or the startup. We have sometimes there's a product changeover, we have a system changeover or design. Sometimes we have a system material or material changes, and sometimes we have the maintenance team have to go through a checklist. And and the other thing is the in process quality. Every time we do a manufacture, and when the product comes, we need to calibrate the product, or we need to check the product whether there's a defect, or whether it's a reject, or maybe there's some modification that needs to be done. Okay, so from this image we can see what the elements of EE being displayed as a bar chart. The first one, we can see that it's an all time. That all time is basically an ideal condition that is not is will never exist in a real world. Okay, the second one is the plan production time. Whatever that we plan inside a manufacturing time, there will always be schedule loss. Maybe this schedule loss can be a factor of sometimes there's maybe death, or maybe sometimes that we a pandemic that we never foresee will be coming. Okay, the third one, we have a runtime. This runtime will be affected by one of the key factor on OE, which is availability. So we have the runtime minus the availability loss, and then we have the net runtime, and the second factor of OE, which is the performance loss, and then we have the fully productive time, which is the quality loss on the third factor of OEE. So what is the significance of OEE? OEE was first used in 1960 by Seiichi Nakajima. He's a founder for TPM. So in an ideal factory, the operating will be 100% capacity and 100% quality, which means this is a 1-to-1 efficiency. That is not will never be exist in a real world condition. And then we have also the losses account for the discrepancy between the ideal and actual situation. This is the where OEE will play a part in, because we are calculating what is the ideal and actual, and when you minus it, we can get where we need to improve on the OEE. So this is the sample calculation for OEE. This is the basic and the most simplest term that we can find. Okay, number one, if you want to find OEE, we have to find the three factors, which is the availability, the performance, and the quality. So when we talk about availability, what is the runtime and the planned production time? For example, if you have a machine that is running for 5 hours and it's idling for 1 hour, so basically it's 5 divided by 6 times 100%. So we get 83.33%. And then the other one, we have the performance factor. Performance factor is the ideal cycle time times the total count divided by the runtime. For example, we have a machine that is producing a steel tube for 40 meter per hour, but the machine was only making 32 meter per hour. Therefore, we can divide 32 divide by 40 and times 100%, we can get 80% performance factor. And then we have quality factor, which is the good count divided by the total count. So for example, in the steel tube production in a day, we produce at 240 meter product, but 50 meter of the steel tube is defected. So 240 meter divided by 50 meter that was defect divided by the whole thing of whole production of the steel tube, which is 240. So we get at 76%. And then we can calculate the overall equipment effectiveness based on the factors that we just calculated, which is the availability, the performance, and the quality factor. And we total up, we get 50.66% of overall equipment effectiveness. So that is the OEE. And also for the OEE, we can actually calculate the planning factor. For example, we have a machine that requires annual maintenance, and we have team to assign to other machine in orders or the orders will be insufficient. For example, the maintenance require 46 days downtime for all all the machine to be maintained, and the factory is operating at 365 days a year. Therefore, 365 minus by 46, we can get 88.7% of the planning factor. So from OEE and planning factor, we can calculate the total productivity. OEE times the planning factor, we can get 50.66% that we just calculated just now, and we can get 88.8% from the planning factor. We counted to 44.97%. Okay, this is another sample calculation for OEE. This one is based on the minutes. For example, we have from the first row, the row A, we have a given total time schedule at 480 minutes. And at B, we have a planned downtime. Based on the planned downtime, sometimes we have a shift change, and then we have a break for all the workers to take a break and lunch, and then another break, and other maybe go to for a prayer. So we sum up all the planned downtime, and then we minus the total time schedule. From there, we can get the planned production time. So based on planned production time, we can get the availability factor, the first factor, which is the availability. So from all the data collected of all the unplanned downtime, other than the planned downtime, maybe something just happened. Maybe it's a rainy day. We cannot run on a rainy day. So and then we get the operation time, the whole day operation time, which is minus the unplanned downtime, and we can get the availability factor, which is at 97.44%. And then we have a bit from the green row, we go to the performance factor. Based on the operation time that we had just now, we can get the availability factor. From the availability factor that we get just now, we can get the performance factor. For example, we have a total piece of unit produced in that 480 minutes per day, which is 1,000 pieces, and the ideal rate of machine producing at 3 pieces per minute. Based on that, we can get the 87.72% performance factor. And the third and last factor, which is the quality factor. So what is the acceptable or undefected product that we produces, which is at 990 pieces. So we have 10 of the product that we produce is defected. So we calculate that based on the percentage, we can get 99%. So from there, we already have the availability factor, we have the performance factor, and we have the quality factor. We can just sum up to the OEE, and we can get at 84.62%. So I'll pass down to my colleague, Mr. Park Tang Seng.
Good day to everyone. So I will proceed with the presentation. So now we talk about this TPM and OEE relationship. So OEE is a powerful tool in the TPM. By the father, who had created this TPM, Mr. Nagajima, have in fact also should be credited with the development of the OEE methodology itself. So what actually has prompted Mr. Nakajima to develop the OEE because he was unsatisfied with the traditional method used to calculate the efficiency and proceed to develop a more complicated method which comprised of the availability, performance, and quality, as I mentioned by my colleague just now. Next slide, please. OEE and IDA also have a relationship by itself. So if we compare OEE with a product multiplication amount, availability, performance, and quality, with the result is equal to information time decision time quality. What's information? That is to identify the constraint and losses. Then you capture all the loss information and subsequently you pass it down to make a decision to pick up the top loss which contributed to the efficiency in the process. Then you decide on the countermeasure to be taken either by inspection or maintenance, either by improvement of this competency and skill of the worker. For example, just to pick a few example, and it helps on to carry out the action. That is to implement the countermeasure and capture what you have learned. It will give you a result close the gap in between your idea and desire stage. Next slide, please. So this slide, I've give an example just to meet the overall pictures of what we discussed previously and what is all the ideas for about. So in the first column, we have availability, performance, and quality in all the different cases. First cases is the ideal condition. Then it's a quite means the ideal lah, so it's very in the fairyland. So the second one is a normal what you can achieve your current process at the equipment. And thirdly is this existing what we achieve after we have gone through with the measurement and calculation. And we from there we know a gap is a subtraction of the normal from subtraction of existing from the normal. So what we our objective now is to close the gap. What we are supposed to do. Um, uh, Now we benchmark the OEE. What is the good OEE score for? 100% OEE means that the perfect production, manufacture only good parts as far as possible and with no stoppage time. 85% is considered a world class for a discrete manufacturing. For many companies, a long-term target. Only 60% is not uncommon in the manufacturing line, but that indicate there's a room for improvement. OEE of 40% is generally considered not considered unacceptable, but it's not uncommon for manufacturing company. It's something for to track and improve the manufacturing performance and to get better and better subsequently. Next one. I'm talking a bit of loss identification and before I pass it to my colleague. So as far as the availability factor is concerned, equipment failure that contributed to availability loss consists of three major categories. The first is the major equipment failures, electrical failure, structural failure, people call unexpected shutdown. And then product transition and changes also is another factor. And thirdly, the downtime defective product that occur when one part of the machine is shut down and the other part is go for setting and adjustment, then also have caused the problems. So the downside would depend on this tool and equipment consistency, the level of maintenance of the equipment, as well as the process standard dictate the process, the operation. Okay, I finalize to touch a bit on this performance related loss. Idling and minor stop. What's idling and minor stop is actually related to this machine is temporary shutdown or malfunction or idling. The factor could be defective product, disruption of the production line, like for example, lack of product or raw material, line saturation where the product had no place to go, or you had no choice but to shut down the machine. Dependent on this assembly component, operator or other machine or lack of training or lack of competency or experience. And finally, temporary equipment malfunction. Okay, I end my presentation here. I pass it to my next colleague.
Okay, hi. I will continue about performance loss identification under slow cycle. So, for example, some part that not be able to run at a machine maximum speed caused by mechanical problem. Risk of making of spec part at higher speed, lack of training, machine nature as the part manufactured range from different size, and a larger size run at a lower speed. Under quality factor, loss identification can be identified in two categories, which is startup loss and quality defect. For startup loss, this type of loss could be yield loss during the early stage of the production, which machine startup, warm up, learning phase to actual production of a quality and consistent product. The degree of the loss depend on the tooling, operator training, equipment maintenance level, and raw material. So under quality defects, which is more related to scrap and rework job, which is losses in quality due to equipment malfunction or tooling malfunction. The degree depend on tooling, equipment maintenance level, raw material operator training, and adherence to SOP. Some other points is some product are difficult to make. There are more breakdown and quality problems. Other than that, in order to save cost, someone has to purchase cheap product, cheap but poor quality raw material. So it will lead to quality defects. Next slide. So this is a little bit of summary come out from availability loss, performance loss, and quality loss. So for example, for availability loss, two types of loss is unplanned stop and planned stop. Example is equipment failure and setup and adjustment for planned stop. Another is performance loss, which come out from loss type of small stop and slow cycle. So example for small stop, idling and minor stop. For slow cycle, which reduce machine speed lah. So under that is quality loss, which come from production defects and startup defects. Production defects, example of loss elevation, we can take out from process problem. Startup defect, we can identify by yield reduction. So from the loss, we need to, after the loss we identify, we need to do the OEE improvement. So under OEE improvement, first part we need to identify the improvement plan. The step is we need to collect all the data times, breakdown, losses on the production. So from the data we need to analyze further, we forecast variable measures to be taken and planning and implement improvement for the production. So this is the most important step in order to increase OEE lah, to improve the OEE. So another about OEE improvement, we can divide into three categories, which is for availability is unplanned stop. We can improve by, if it have equipment failure, we can improve by increasing the lifespan of MTBF, mean time failure. Another that for plan stop under availability element, we need to set up an adjustment of the machine, improve precision in setup and adjustment, provide virtual and enhanced training to our staff, and use original or OEM parts. Under performance is small stop and slow cycle. Example of the small stop is idling and number of stop, and slow cycle is loss is reducing speed. So in order to improve, we need to enhance process improvement and carry out for reduce speed. We need to carry regular maintenance and inspection in order to get what the speed that we need lah in our production. So under quality loss, the production defect and startup defects. So example, we can improve through process problem. We can carry out a statistic performance chart, which is we know the upper limit and lower limit for the process. So in order if have problem, we can identify early. So for startup defects, we can, example, we can improve in yield reduction. So we need to improve in run consistent product to avoid frequent changeover. So other than that, another factor that can improve OEE, the operator may further have training and refresher training. Bottleneck equipment may require technology changes. Production schedule may be to fine tune. Good Goods may need to be redesigned. Operating instruction may need to review, strengthen maintenance and inspection program. Among the inspection include conditional monitoring, analysis, motor impedance check, loop oil check, and etc. Carry out a periodic audit, and some of this improvement may require some investment. With good investment, OE can be implemented and can be improved lah. So for the conclusion, OEE is a very good tool that able to track performance of manufacturing operation and made it feasible by accurate measurement and improvement. So it can impact the bottom line. For example, it can affect the cost, waste, and loss reduction. Increase productivity by increased ability, performance, and quality. So it also can give us greater job certification, just satisfaction, and motivation. So that's all for our presentation.
Okay, all right. Thank you. That's all.